Hello students, in today's class we will discuss few interesting questions and based on biquadratic denominator. This is reducible to quadratic denominator. So basically completion square method. Okay. The first question is x square minus 1 by x power 4 plus 1 dx. What is the point to be noted? The denominator x power 4 and 1. What is the square root of x power 4 x square? What is the square root of 1? 1 of the square root of 1 is minus 1. 1 of the square root of x power 4 is x square. So the square root of the x power 4 term and constant term should exist in the numerator. This is the key point. Once again, square root of highest degree term, that is x power 4 and constant term of the denominator should exist in the numerator. So this is the type of the question. Now once look at here, what is the square root of x power 4 x square? Square root of 1 is minus 1. Now this is in standard form. In standard form. Once the integral in standard form with the biquadratic denominator, what to do? So divide numerator and the denominator by x square. So I equal to this x square by x square 1 minus 1 minus x square dx. This is obtained by dividing numerator by x square. The denominator x square plus 1 by x square. Okay, you know what to do? Write the numerator antiderivative. So derivative of x is nothing but 1 and derivative of plus 1 by x is nothing but minus 1 by square. So x plus 1 by x. So better write the denominator x square plus 1 by x square in term of x plus 1 by x plus 1 by x the whole square, middle term plus 2, to adjust the plus 2 minus 2. Now the numerator is the derivative of x plus or differential of x plus 1 by x means this is new variable. So we are going to integrate with respect to the new variable x plus 1 by x. So put and t equal to x plus 1 by x, then this is dt, then I equal to dt by t square minus root of 2 square. So the difference of variable square and constant square 1 by 2a log mod of, and difference of these two divided by sum of these two. So final answer I equal to 1 by 2 a is nothing but root of 2 log mod of t minus root of 2, so divided by t plus root of 2 with integral constant to give the final answer in term of x, because in term of x in the given variable replace t by, what is t? X plus 1 by x plus 1 by x minus root of 2 and x plus 1 by x plus root of 2 in the denominator. On further simplification, 1 by 2 root of 2 log mod of x square minus root of 2x plus 1 x square plus root of 2 plus 1 with the integral constant. So this is the final answers. Go through it. We will discuss a few more questions. So one more similar question we are going to discuss. Look at the denominator biquadratic x power 4 and 4, square root of x power 4 x square and square root of 4 is 2. So this is already in standard form. So now what to do? Divide numerator and denominator by x square. Then I equal to x square by x square 1 plus 2 by x square dx, then x square plus 4 by x square. Now, so let us write numerators d of something. To write d of something, just integral of these two terms should be written within the bracket, so that the derivative of integral of this the same. So x minus 2 by x. Then the denominator should be written x minus 2 by x, x minus 2 by x, because this is new variable, whole square. So in the expansion we have x square and 4 by x square, in the middle term minus 4, so plus 4 is written 2 square. Now if we expand it, we can get x square plus 4 by x square. Let us now take t equal to x minus 2 minus x, and numerator is dt, then I equal to dt by t square plus 2 square. So this is regular formula, 1 by a tan inverse of t by 2. So I equal to 1 by a is nothing but 2, and tan inverse of the ratio of variable to the constant term, so t by 2 with the integral constant. So the final answer 1 by 2 in term of x, tan inverse of t is nothing but x minus 2 by x, x minus 2 by x by 2 plus c. On further simplification, this is tan inverse of x square minus 2 by 2x with the integral constants. Go through it. The next question, 1 by x power 4 plus 16. So dear student, this is not in the standard form. Why? Because square root of x power 4 does not exist in the numerator, as well as square root of 16 also is not available in the numerator. So deliberately we need x square term and root of 16 4. So x square and 4 should be included in the numerator. Okay, the first for to get 4, so make it note 4 plus 4. How to write? X square plus 4 minus of x square minus 4, just then x power 4 plus 16 dx. If we simplify the numerator, x square and x square cancel, no problem. But 4 minus or minus 4, 4 plus 4, 8. So 8 is additional factor, out to balance additional factor. Divide the entire integrand by 8 and keep the dividing factor outside of the integral. Now this is nothing but the given integral dx by x power 4 plus 16 and satisfying the standard equation. And square root of x power 4 x square root of 16 4, square root of x power 4 x square root of 16 minus 4. So better we can separate into two integral, 1 by 8 integral of x square plus 4 by x power 4 plus 16 dx minus 1 by 8 integral of x square minus 4 by x power 4 plus 16, and both I1 and I2 in standard form. So because of standard form, a regular method, divide numerator and denominator by x square. So 1 by 8 and 1 plus 4 by x square by x square plus 16 by x square dx. This is first part, first integral, that is I1 minus 1 by 8, 1 minus 4 by x square divided by x square by 16 by x square is I2. Now then as usual 1 by 8, write numerator as a derivative of integral of 1 is x, derivative of x is 1, and minus here, plus mean here minus 4 by x. So derivative of minus 4 by x plus 4 by x square. At the same time, this is a new variable of the first integrand. So denominator should be written in term of x minus 4 by x, x minus 4 by x the whole square. So middle term minus 8, So plus 8 2 root of 2 the whole square. Then minus 1 by 8. Then this is derivative of x minus 1 plus 4 by x. So better write x plus 4 by x whole square denominator minus 2 root of 2 the whole square. Okay. Now the two integrals are readily integrable. The first part x minus 4 by x u, the second term x plus 4 by x v. So let us take x minus 4 by x as u and x plus 4 by x as v. Then I equal to 1 by 8 du by u square plus 2 root of 2 the whole square minus 1 by 8 dv by v square minus 2 root of 2 the whole square. Now applying suitable formula, this is other than 1 by 8, 1 by a, 1 by 2 root of 2 and tan inverse of the ratio of these two, u by 2 root of 2. This is for the first integral. Minus 1 by 8. 1 by 2 root of 2 means that is 4 root of 2 log mod of v minus 2 root of 2 and v plus 2 root of 2. Overall c is the integral constant. Now after simplification and conversion, so 1 by 16 root of 2 tan inverse of, so what about u? U equal to x minus 4 by x. X minus 4 by x by 2 root of x or x square minus 4. X square minus 4 by 2 root of 2x. And minus 1 by 8 times 4 32. 1 by 32 root of 2 a log mod of, and this is x square plus 4 by x. X square plus 4 by x minus 2 root of 2 means minus 2 root of 2x. So divided by x square plus 4 plus 2 root of 2x with the integral constant. So this is the final answer. So this type of question is very important. Whenever the standard form of biquadratic type of integral has some problem, adjust like that. So identify the square root of these two terms here, x square and 4. So adjust the numerator in term of x square plus 4 and x square minus 4 so that the simplified value should be constant. We will discuss one more question. The next question also, the numerator free, numerator is 1, but denominator biquadratic x power 4 plus 36 means what are the two terms required, x square and 6. So we can adjust the numerator in term of x square and 6. So I equal to x square plus 6 minus of x square minus 6, 6 plus 6 12, so 1 by 12 outside, then x power 4 plus 36. Okay, so by addition and subtraction we have adjusted the given integral. This is nothing but the original integral 1 by x power 4 plus 36, but the numerator is a integral of the highest degree term and a least degree term in both the terms. So better we can separate into two integrals. I equal to 1 by 12 integral of x square plus 6 upon x power 4 plus 36 dx minus 1 by 12 integral of x square minus 6 by x power 4 plus 36 dx. Then divide because of in standard form numerator and denominator by which term, x square. So after dividing every term numerator and denominator by x square, 1 plus 6 by x square and dx, denominator x square plus 36 by x square. This is I1 minus 1 by 12 and 1 minus 6 by x square dx, the denominator x square plus 36 by x square. So let us now write numerator as a derivative of one group. So derivative of this is nothing but integral of these two terms, x minus 6 by x. So denominator also x minus 6 by x the whole square in term of this. So middle term minus 12, so plus 12 2 root of 3 the whole square. Okay, then minus 1 by 12 integral of and derivative of x plus 6 by x, then x plus 6 by x the whole square, middle term plus 12, so minus 2 root of 3 the whole square. Now we can take x minus 6 by x is the first variable u and x plus 6 by x is the second variable v. So let u equal to x minus 6 by x and v equal to x plus 6 by x. Okay, then I equal to 1 by 12 du by u square plus 2 root of 3 the whole square minus 1 by 12 du by v square minus 2 root of 3 whole square. So applying suitable integral formula, then 1 by 12, this is I1, 1 by 2 root of 3 tan inverse of the ratio of these two, u by 2 root of 3 minus 1 by 12, then 1 by 2 a 4 root of 3 log mod of v minus and 2 root of 3 is divided by v plus 2 root of 3 overall integral constant c. So what is u? X square minus 6 by x. So I equal to 1 by 24 root 3 and tan inverse of u equal to, substituting the value of u, x square minus 6 by 2 root 3 x minus 1 by 12 and 12 into 4 48 root of 3 log mod of and v equal to x square plus 6. So x square plus 6 minus 2 root of 3x is divided by x square plus 6 plus 2 root of 3x after simplification. So this is the final answers. Go through it. In the coming videos we will discuss few more questions of this type for your better exposure. So my dear student, my humble request to all of you, my channel name S.MURUGAIYAN. I have done all this only for the benefit of 12th standard students of our country. So let us all work together for the benefit of 12th standard students. To support my effort, subscribe my videos and like my videos and share my video link in all possible ways for all 12th standard students of your school and other schools and known students. So thank you student, thank you very much for watching my channel. Thank you.